So in this video, I'm going to explain about data transfer or data copying instructions in 8085, and this instruction is more frequently used in the programming part for this 8085. So the basic function of this move instruction is it will copy the data from source to destination without making any change in the content of source here. So the opcode used here, it is as a MOV, and their operand will be this side it is destination register, this side it is source register. And another variation of this move instruction is we can take it here move, and this as a operand we can take their destination as a memory and their source as a source register RS. Similarly, the next variant is move, and this side it is having destination register and this side it is having memory. So in this case, in the first case, what it is happening, it will copy the data from source register to destination register. For example, let's say as like move C comma B. So here this C and B both are processor register, and here how it will operate, it will copy the content of B register into C register without making any change into the content of this B register. So here this both the sides it has taken as a register, that is called processor register only. And the second variation is move M comma RS. So let's say that is move M comma D. So here move M comma D means it is moving or copying the content of D register into the memory location. And at which memory location? The memory location which is pointed out by the HL register pair. So the next variation of this move instruction is as like we can say it here as a move C comma M. So in this case of the instruction, it will copy the data from the memory location which is pointed by the HL register pair, and it is storing into this C register. So in this case, this C is the processor register, but M is outside of the processor, which is called as a memory here. So now based on this, we can write down their size as like I had explained, that if the instruction containing only English alphabet, then this can be recognized as 1 byte of the instruction as a their size. So these all the variants it is treated here as a 1 byte. This is also 1 byte. This is also 1 byte. Now we'll come to this machine cycle. So as I had explained, the minimum size for any instruction must be 1 byte, and the minimum number of machine cycle required for any instruction is 1 machine cycle. So this move C comma B, it is 1 byte instruction, and this is having only 1 machine cycle. How we can say that? Why we can say that it is having only 1 machine cycle? So by default, for example, let's say this is 1 byte instruction and their hex code is stored at this 2001H. So let's say their hex code is as a XXH. So this XXH as a opcode, it will come from memory to the processor, to this microprocessor, and after execution of their opcode, processor is knowing that their operand as a processor register is available inside the processor itself. So there is no need to further access of memory or IO device. So that is the reason it is required only 1 machine cycle, and that machine cycle is called here. That machine cycle is called here as a 1 machine cycle, and their name will be opcode fetch operation. Opcode fetch operation. And as per the table I had given, this opcode fetch operation, it will take minimum of one machine cycle. It means it is taking 4 T state here. So the number of T state will be 4 only. So I had given as a opcode fetch operation, it will take 40 state as a minimum and maximum will be 60 state. So there are very few instruction which is required 60 state as per their opcode fetch operation. So their list and reason will explain further. As of now, we should understand about that move C comma B is required only 1 byte, because this all is having English alphabets only without having any kind of 8 bit of immediate data or 16 bit of immediate data. So this contains only this English alphabet, so that is the reason it is called 1 byte of instruction. And the very first operation for any instruction is that operation is called as a opcode fetch operation. So here whenever this opcode is coming for this instruction from this memory to this processor, then it is knowing that the operand for this instruction is available inside the processor itself. So it is accessing outside of the processor as a memory or IO only once. So that is the reason their machine cycle is referred here as a 1, and that operation is called as a opcode fetch operation. And for the opcode fetch operation, the minimum number of T state required is 4 T state, and I can say that most of the instructions in 8085 is having opcode fetch operation as a 4 T state only. There are very few which is required 60 state, so that will explain further why it is required 60 state and for which instruction it is required 60 state as a opcode fetch operation. Now we'll come to this second and third variant of this operation, like for this move instruction. So how we can identify their machine cycle here? So first of all, by default for any instruction their first operation is opcode fetch operation. So for this one their first operation is opcode fetch operation, and after execution of this instruction or after performing this opcode fetch instruction, it is knowing that this source register we need to move as like the content of D register which is available inside the processor, we need it to move to the memory which is pointed by the HL register pair. For example, let's say before execution of this instruction move M comma D, if HL register pair is having some data of this is H, this is L, this is 20, this is 02H. So this HL will point to this memory by their address to this location as a 2002H, and at this point, at this location, what will happen? The D register content which is available inside the processor is going to store at this location. So that is the function of this move M comma D. So how many times it is accessing this memory? First is to read their opcode. Wherever it is stored from that location, it is going to read their opcode, and after then it is going to store the content of D register into the memory location whose address is given here as a 2002H by this HL register pair. So ultimately it is accessing 2 times of this memory chip. So that is the reason their machine cycle required will be 2 machine cycle here. And what are those operation? So the operation will be by default, first operation will be opcode fetch operation. And the second operation will be we are storing the content of this D register which is available inside the processor into the memory. It means storing is called as a writing operation inside the memory. So we can say that second operation is called here as a memory write operation. So as we know that for opcode fetch operation it is taking only 40 state. So we can write it here as a 40 state for this opcode fetch, and for rest of the operation as like memory read or memory write, IO read, IO write, it will take each operation only 3 T state. So that I had given in the table also. So for memory write it will take 3 T state. So total it will take 7 T state to operate or to execute this instruction as a move M comma D. So for the successful execution of this move M comma D, it will take 7 T state. It means 7 T state means 7 clock cycle or 7 clock period it is required for the complete execution of this move M comma D. Similarly, for this move C comma M, the functionality for this instruction is it is copying the content of memory. Which memory? The memory which is pointed by HL register pair, and that content will move into the C register inside the processor. So now the very first operation for this instruction will be what? The very first operation is opcode fetch operation. The very first operation is opcode fetch operation. After then, it is understanding, this microprocessor is understanding that the data which is going to be stored into C register must have to come outside from the processor, from the memory. So which memory location? Whose address is pointed by HL register pair. So let's say now this HL content is here as a 2003H, and before execution of this instruction at this 2003H some data is here as like I can say 4CH. So what will happen? First of all, this will perform that opcode fetching. This move C comma M will perform opcode fetch operation. So that will take 4 T state, and the second operation will be copying this content as a 4CH into the C register of this microprocessor. So for execution of this instruction, it is accessing memory 2 times. It is accessing this memory 2 times. So their machine cycle will be 2 here, and that is called first operation. It will be opcode fetch operation, and second operation will be what? Second operation will be memory read, because it is reading the content at this location, from this location 2003H, which is pointed by HL register pair into where? Into this C register. So machine cycle is basically recognized here how many times microprocessor is accessing this memory chip for the operation of opcode fetch or memory read or memory write, and this is recognized another way that how many times it is accessing IO chip for IO read or IO write. So some of those are called their number of machine cycle. So based on that, here move C comma M, it is required for the complete execution of this instruction. It is accessing this memory chip 2 times. First is for the opcode fetch. Once it is getting the opcode fetch, so during the decoding and execution part of this opcode fetch, this microprocessor is understanding that their operand which is going to be stored into C register is outside of the processor. It means it is accessing from the memory. This M denotes as a memory. Which memory location? Which is pointed by HL register pair. So what is the content of this HL is treated here as a memory address, and at that memory address what is the content? It is moving into C register. So totally it is accessing 2 times of this memory chip. First operation is opcode fetch operation, and second operation it is reading this data from the memory chip to the processor. So that is called memory read operation. So as I had given, opcode fetch will take 4 T state and memory read will also take 3 T state. So total number of T state required is 7 T state for this instruction move C comma M. So here we can say that what is the basic difference between this and this? Both is having the similarity, both is having 1 byte of their size, and their total number of machine cycle is 2 machine cycle for this move M comma RS or move RD comma M also. And the second similarity is their number of T state is same, 7, but their dissimilarity is there. In this case move M comma RS, the second operation is memory write, and for this move RD comma M, their second operation is memory read. So by this way, I hope you learn about this move instruction and their parameters, how to find out their size, machine cycle and T state. So next we'll see in the further video as a instruction MVI.